So the focus on this video really is to show you that you can do comparative analysis in here. So if I just had two conditions, so my control and condition 1, I could go ahead and do a t-test, something called a student t-test in Excel. But in this case, I don't have just my control in one condition, I have my control and 3 other conditions. So in that case, you use an analysis that's called analysis of variance, and this allows you to do multiple comparisons. So in Excel, unfortunately, these functions are not already there. You're going to have to enable it if you haven't done it already. Add this analysis toolpack function. You go to file, and then right at the bottom, if you're using Office 365, you can select options, and in options you can choose add-ins and hit go. Then you check the analysis toolpack and you will find the analysis toolpack now appears, and you're able to use it and look at the set of analyses you can do here. So to get it, you go to file and options, then in the left hand side you've got all these options. You can go to add-ins, and when you go to add-ins, you're tempted to go into data, but it's not actually in data, it's in add-ins. So in add-ins, you can go ahead and select analysis toolpack. The next thing to do is select go. And once you select go, you get a little pop-up box and you select once again analysis toolpack. Other options: analysis toolpack, VBA, Euro currency tools, solver, add-ins. If that's applicable, you can select them. But I'm just going to leave it at analysis toolpack. And this provides data analysis tools for statistical and engineering analysis. Now, if you go into Excel and hit the data tab, you see that we now have analysis, data analysis enabled. If you click on it, it will show you the range of analyses you can do. So you can see I can do ANOVA single factor, ANOVA two-factor with replication, ANOVA two-factor without replication. You can do correlation, you can do covariance, you can do descriptive statistics, exponential smoothing, F-test, two-sample analysis, you can do histograms, Fourier transforms, sampling, you can do t-tests, you can do z-tests, so we can do regression. So that's the options that are now available for you. And in this case, I'm going to be using analysis of variance single factor. Select analysis of variance ANOVA for short and single factor, and it asks you the input range. So what are you trying to compare? And in this case, I've moved the average to a particular row so I can compare those. So I'm just going to go ahead and select those as my comparisons. So I've selected that, and you can also tell it where you want it to put the data. Before we go into that, you see that it's got an alpha of 0.05, and that's the threshold, the probability at what point you want to reject what is called the null hypothesis. The null hypothesis always states that there's no difference, don't worry about it, go home, there's nothing here. And so you want to set a significant probability level where you will say, if it is, then there is a difference. I don't think that this is all by chance. And so it's usually set at, well, just a standard, just by convention, minimum 5%. So as the decimal is 0.05, and so that's what is already there as 0.05. If you want to tighten that, if say you want 99% confidence that the null hypothesis that nothing is happening, that there are no differences, if you want to do that, then you will go to 0.01. But in this case 0.05 is fine. And then the output, you say where you want it. Do you want it in the same page that you're working on, or maybe you want it on a new worksheet, or maybe a new workbook entirely? So you get to select that. So I'm going to go ahead and say that I want it exactly where I'm working. You could have also indicated how your data that you're comparing is set. So is it grouped by columns or rows? In my case, it's by columns, so I leave it as columns. But if I had put it as rows, then I could change that as well. Now note that for calculation of your t-test, if it's a t-test or analysis of variance in this case, the input data is actually not your summary data. So it's not the mean and the standard deviation. You want to give it the raw value for each of the reads. And this is because it's going to need to measure, it's going to need to know the variance in order to give you whether things are statistically significant or not. So go ahead and bring the raw values under their own heading. So I've got my control, condition 1, condition 2, and condition 3, and I've got all the raw values that I obtained, the raw concentrations, which, as I said, were measured off of an absorbance reading. So that's going to be your input values. Just a tip here, when you're copying and pasting in Excel, remember to paste the values rather than the functions, because then it would try and do calculations wherever you move particular data from one cell to the other. So to avoid that, just paste the values itself. So when you're selecting your analysis from the tool pack, you can include, for the analysis of variance, you can include the headings for the data sets. And if you do, you have to remember to select labels in first row so that it knows those values are labels. Otherwise, it will tell you that you've got non-quantitative data in this data set, and it won't be able to calculate for you this. It won't be able to do the analysis of variance, the comparisons. If you're doing the output range on the same spreadsheet, then just select an area that you want it to place it in. It insists that you tell it where it puts it. It's not going to just pop it anywhere. So that's, otherwise it won't work either. So remember to select an area in your sheet where it can put the results. As you can see from the output based on this data set, it actually will give you the averages anywhere, which is, if you see, will match the averages that you would have calculated in order to do the visualization, to do the graphs. And it also tells you what the variance is, tells you the count, so how many values were in each group, and in this case it's 7. And so it matches whatever functions you would have calculated, formulas you would have calculated initially. If you look at the table where it's going to tell you whether you have differences, which is based on the p-value, you can see that we have a p-value of 0.001852, and this indicates this is less than 0.05, so it indicates that there is significance. What do each of these other values mean? So you've got the SS, which is the sum of squares. Now the SS is looking at the variability between or within the groups. Then the DF is the degrees of freedom. So the degrees of freedom is calculated differently for the two groups, or the two, like whether you're looking at between groups or within groups. So for between the groups, you look at the number of groups that you have, and then you take away 1. That's just what the formula is. So the number of groups that I have in this case, I had the control, and then I had the 3 conditions. So I had 4. So if I take 1 from 4, then I've got 3, and that's why the 3 appears. But then within groups, what you do is look at the total number of observations that you had. So in my case, I had 7 in each group, and I have 4 different conditions. So I have 28 observations, and then the number of groups, I've got the control and the 3 conditions, so it's 4. So once again, it's just 28, which was the total observations, because I have 4 different groups and I've got 7 in each, and then I take away the number of groups, which is 4, and that's why I have 24 cos 28 minus 4. Then you've got MS. So MS stands for the mean square. So it's like an average of the variation. So remember, like the mean is like the average of the observations. Well, MS is like the average of the variations. And it's within and between the groups, because you have the 2 comparisons that you're doing. So how it's calculated is that the sum of squares for the between groups, for instance, is divided by the degrees of freedom. And if it's the within groups, then the sum of squares is divided by its degrees of freedom. You've got F, and you've got the F critical. The F statistic and F critical values are what determine whether the p-value is significant or not. F value, or the F statistic, is actually calculated from the ratio of your mean square values for the ones that you compared between groups and within groups. So for this data set, when we did the ratio of the within and the between, we get a ratio of 6.7444. And so when you have a look at the F critical, this is the critical value that we needed to meet or exceed if we were dealing with situations where things were significantly different. And so you can see that we have exceeded it. We needed 3.008 in order to be at a significance value between the conditions, and we've actually, when we do the ratio, we're at 6.744, and so it's no wonder then that our p-value is significant. And yeah, so that's how those variables play out. Now, it's important to mention here that with your analysis of variance, you've got multiple conditions or multiple groups that you've compared. And so this test will just tell you if there are differences in any of them. It doesn't actually tell you where the difference lies. And so this is where you need what's called a post hoc analysis to really identify which of the conditions, which of the multiple groups that you're comparing have the difference. And so that's a totally different video, but I'm going to leave this one here on just analysis of variance. And I hope that you learned something, and yeah, comment on how you've used this test in your experiments.